has been able to log in successfully. So my name is Charlie Krause from Limelight Networks, and I look after all of our live video, on-demand video, and security services from a product marketing perspective. So what we're going to talk about today is basically very fast live stream delivery, sub-second delivery. And the reason for this topic is online gambling, gaming, and sports betting and so forth will only really be truly successful when it's done online for remote users if the latency is really reduced compared to what we're used to with live streaming. So we're going to talk about some technologies that let you do that. And everything I talk about is going to have a focus around gaming and so forth. So there's several challenges we're going to talk about that you're probably aware of, about the large number of user devices that are out there. There's some inherent technical reasons why latency is typically long on streaming. We'll talk about a technology called WEBRTC that can solve a lot of this. And we'll talk about interactivity that you can have along with it, and then how to protect your content. So one of the things I do every year is I survey the market globally, about a dozen countries around the world, about their habits in viewing online video and basically any use case. And one of the things that's happened this year is, for the first time, mobile first has come up. Up till now, it's been basically PCs, computers that dominated in terms of watching any kind of live video. But this year, any kind of mobile, so the combination of smartphones, tablets, etc., flipped, and that is the preferred way to watch online, whether it's big movies on OTT or watching sports, basically any online kind of activity. It's definitely gone mobile. Of course, latency has been an issue. The way this typically manifests, people always see that. If they're watching a football game on a mobile and a friend might be watching in a sports pub, and you could get a text about a great goal that was just scored, and you haven't seen it yet, and then 30 seconds later you see it. So it's kind of an annoyance, and we'll talk about why that is and what you can do about it. And then the other thing is just this general issue of streaming and broadcast, and why this big gap, and some very simple ways at scale that this can be addressed. So let's get into this. So the challenge is, lots of devices and formats, the global scale and reach. Depending, sometimes just regional is all you need to do to distribute video, but many use cases, you're really going after a global audience, and you need a good global CDN to do that. We talked about mobile first, and because of the gaming industry, we really can't ignore the whole idea of not only protecting video content, but your gamers that are online. It's sort of gambling is sort of the perfect storm of vast sums of money, lots of private data, et cetera. So it's a very important topic. So the issue with broadcast, so a lot of people think broadcast doesn't have any latency, but it does. So from the camera, I'm going to define latency as the camera lens at an event, from that point until you, anywhere you are, see on your screen. So that's a very conservative, rigorous test of latency. And right now, for typical cable broadcast television of all sorts, that latency is in the 5 to 8 second range, typically. Online streaming, typically, though, is about 30 seconds because it's done by something called chunked encoding. So the normal way that HLS and Dash and other chunked video formats are put out is to have 10-second chunks and use 3 of them to build a buffer. And so right off, just that alone causes a 30-second delay. And then there's other delays around encoding and so forth. So it can add up to maybe 45 seconds or so. But if you can get this online latency down to 5 to 8 seconds, you will at least keep the live streams in sync with what's going on the broadcasts. So that's a really good goal to have. So OTT delivery, in the second part here, we want to make sure that that's down to 5 seconds. So we're going to take 2 looks at this. One is from a technology perspective. So typical HLS Dash, as I mentioned, can be 30 to 60 seconds. If you use small chunk streaming and you take the chunk size from 10 seconds down to maybe one second or 2 seconds, you can match the cable TV latency of 5 to 8 seconds. And that little zone between that I call the text spoiler zone is what we're talking about, where somebody on a broadcast sees anything and makes a comment on social media, and you pick that up because you're watching on mobile and you haven't seen, or you don't know what the event is. So just that's a really good scalable way to do this, because the global CDN infrastructure can handle HLS and dash chunk streaming all day long at massive numbers of streams. It's been proven out in World Cup football matches where tens of millions of streams are delivered. Another way to do this is low latency CMAF. So CMAF is yet another attempt to try to reduce the number of different technologies used to do streaming. So CMAF itself isn't as a distribution protocol, but it's a way of encoding and building a manifest that both HLS and dash can read and use to deliver the video. And they have a low latency mode, and we'll talk about how that works. And that'll work for a lot of use cases. If you can get down just a little under 5 seconds, that works well. But to really have this true interactivity where people that are remote are really watching the video in the same time frame as people live at the event or people around the globe. So it's not just that it's low latency, but it's consistent latency across all the remote users. Very exciting. Oops, I have the same slide twice for some reason. Okay. The other view of this is by use case versus latency. So you see that I started the 100-second range for typical OTT. When you get down to 5 seconds, this dual screen image I'm showing. So you might be watching, I try this at home to test that. I'll watch a football match on my big home screen, and I'll have my mobile device on the same match. And if I use small chunk streaming, I see them, they're pretty close to seeing the same image. It's not a 30-second gap. If you use CMAF and you get down to the 3 second or so, this works well for company meetings where you may have attendees in headquarters and in remote offices they're in. And if you just have a low latency like that, that's pretty good for a little interactivity. People can ask questions and it's not too bad. But I really get excited about the sub-second, because now you bring in use cases like doing live auction. So you picture an auction room where there's people live, and as they're auctioning, people have their paddles that they put up and bid. And they also have dial-in users that they watch on a video and they're coming in. The problem is that the video that they're seeing, if that's delayed 30 seconds, it's pretty hard to participate with auction bidders in a room. Or big esports games on a monitor, and particularly for today's topic, online gaming. If you're going to play blackjack or Texas Hold'em or roulette or craps online, you're typically looking at a table that's in one of these big warehouses, maybe in Malta, that has hundreds of these table games in live dealers and cameras, but no actual gamers in the facility. So they're watching online. So what you really want is when there's a turn of card, or the ball drops on the roulette wheel, or the dice are rolled on a craps game, that everybody, no matter where they are, sees that action at the same time. And that's, if you can do that, that's really a major breakthrough in being able to handle really good experience for online video. Similarly, sports bet. So it's common now in some regions that for live events, you can go to in a betting parlor. I know you can do this in the UK, and you have an event on the screens, and you can and they offer bets about what's going to happen. It could be a horse race, it could be a soccer match. Somebody's going to score a goal. You want to bet on those outcomes, but you have your mobile has the data, but you have to look at a screen. So this low latency would enable an integrated app where you see the live video and the data about your betting and making offers and placing bets right on the same device. And that's really where we want to go here. So let's go back to the small chunk streaming. So this is a typical workflow that you would probably see on any of the major content delivery networks. So you have your live video camera, you feed it to an encoder, it delivers an RTMP stream to the network edge. And from there, it's transcoded and transmuxed. So you send a high bit rate in, you transcode it down to the different bit rates that different devices need, and you transcode it and transmux it rather for the particular device. Now, the way this works is any of the devices that come in, the CDN edge can detect what that device is. Is it an iOS? Is it an Android? Is it HLS? What's the format they're requested? What's the screen size? So that in delivering the video, the video transmuxing functionality in the CDN can format that video for the right format, screen size, etc., and get the right video delivered. And there's also, most of them have player analytics that they can give you so you know what people are watching. This is a super scalable, global, you can do millions of these all day long. This is what the infrastructure is really good at today. Now for small chunk streaming, looks like the same workflow, but now we're going to be able to reduce the chunk size down to about 1 second. So everything I just said applies, except that instead of a 30-second delay, this is going to probably be about a 5-second delay. So much more, much more sensible for the multi-screen kind of issues. So a little bit more detail about the workflow. So what we're showing is, let's say the highest bit rate we send in is 4 megabits per second for 1080p. The transcode will divide that down into 1080, 720, 480, 360, etc. Any of these bit rates you might need for your devices. And that's all done within the CDN. And then you can see that we have these different devices that want those different bit rates and so forth, and that's where it's going to be delivered. So the video will come out to those. Okay, for some reason, I'm getting doubles of every slide here. That's right. All right. Now, low latency CMAF. So one fundamental difference with CMAF, it uses chunk streaming like we described, but in the low latency mode, it uses something called micro chunks. So instead of being 1 second, 2 seconds, 30 seconds, whatever, they're typically in the 100 millisecond to 200 millisecond range. So they're smaller. But the other fundamental difference is, unlike chunk streaming, where you wait till you have 3 or 4 chunks in your buffer before you start delivering, with low latency CMAF, as soon as these micro chunks start to be delivered, the player can play immediately. So it doesn't wait till an entire segment is built before it starts playing. So that eliminates a huge piece of latency. So as soon as the first micro chunks come in, the players start playing. And that's how it goes. So that's how we can get it down to the 2 to 4 second range. You don't wait for a complete segment. But again, CMAF is not your delivery format. It's just to develop the encoding and the chunking and the manifest. It's HLS or dash that actually is taking this in something called chunk transfer streaming and pulling in these micro chunks and delivering them. And away we go. Interesting. Seems to like this particular slide. So let's get into the topic of sub-second latency streaming. So here we have a Texas Hold'em setup on here, and we have remote users that are going to be coming in. So in these cases, the sub-second latency allows all the players that are remote anywhere to all see what's going on the table, wherever that is, at the same time. The turn of a card, as I mentioned, the dice on the craps table, etc. So it's not only that it's low latency, but it's consistent across all the users. Now, the nice thing here is the technology allows a data channel to be sent as long as the data. So I'll talk about how that's done. But this allows you to build an app that has a data channel, so you can exchange data with the remote users, like offer bets, and they can place bets or say, I want to take another card, etc. And again, everybody is seeing that action happen at the same time. Same kind of thing for live sports betting. So we talked about having the screen, so you could see on that mobile device, there's a soccer match going on. Bets are being offered and placed on the app. And again, because it's so fast, you're not at a disadvantage against fans that are actually at the event that may be betting as well, because the latency is in the few hundred millisecond range. You can place bets about what's going on in the field just as well as they can. So this is using something called WEBRTC, and this is what this workflow looks like. So the difference between WEBRTC and these other formats is this is not chunk streaming. This is done over UDP, or Unreliable Transfer Protocol. So WebRTC is ingested. It's converted to WebRTC at servers at the CDN edge, and it's streamed out. So the difference here and why it's so fast is because it's not chunk streaming, it's just a smooth stream. It doesn't have the latency of building chunks, but it also doesn't have, like HTTP, there's no acknowledgement. So there's no waiting for a segment, acknowledging that you got it and so forth, which adds some of that delay. There's no feedback. You just send the stream out, and it's just best effort. And the way it manages quality is it looks at the player delivery, and if you're delivering the streams faster than it can handle because of the connectivity issues, it drops the speed down. So one of the things that it does at the WebRTC edge is it generates a multi-bit rates. So it has a high bit rate, a medium bit rate, a low bit rate. So it may generate 6 different bit rates, and all of those are available. So if a faster bit rate is too fast for the network connectivity, it starts dropping down to lower bit rates. WebRTC optimizes for low latency. So it will do anything possible to keep that latency low. So if it has to sacrifice a little bit of picture quality and drop down the bit rate, it will do that. But what the idea is always keeping that latency as low as possible. The way this scales is this is not the WebRTC you might think of for Google Hangouts, where it's all peer-to-peer, where you have like 50 people on and they're all sharing video segments with each other. This is a single stream ingesting, and the CDN is basically replicating that stream and sending it out to the edge, where you can replicate it out to thousands or even 1 million or more streams running this way. So it's a whole different paradigm for sending out live video. So scalability, as I mentioned, so you're sending streams in. Always good idea to have primary and secondary ingests so that if something were ever to happen on an ingest, you still have a backup that's right there and do this active. And this is where the streams are distributed to WebRTC streamers at the edge, where it's all replicated. So this right now, there's infrastructure that we have in our network all around the world to be able to do this, and it works very well. Security. So I'm going to talk a little bit more about that soon, but what's built in with this is some very simple things like access control so that only people that are subscribed to be able to watch a stream can get on. Geo-blocking, very important for gaming. Very often you have to, compliance-wise, make sure you block people from gambling from online on regions that don't allow it. So geo-blocking is a way to look at their IP address and know where they're coming from and block them, and even deals with anonymizers. So some people try to get around this by using an anonymizer to disguise their IP address. The geo-blocking software is aware of the anonymizer, still detects it, and will block people. And this is where you can have whitelist and blacklist of IP addresses coming in. You can use tokenization to scramble it, and then you have to have a key given to you to decode the video and watch it. And of course, everything is encrypted by TLS encryption that you go across. So, basic security that comes with the CDN, but we'll talk about other measures shortly. I mentioned the ability to build into the video. Your app can now do data exchange. So to do that, there's software developers kits available for iOS and Android and HTML that lets you build an app and then basically tie the chat to your video. And this allows you to, it basically abstracts the WebRTC from the devices, because you wouldn't want to have to deal with which version of iOS, which version Android, because there's hundreds and hundreds of these different type of versions with all these devices. So it abstracts that. So any mobile device or PC will be able to receive WebRTC streams and play them. So that's how that's done. A cool use case that I want to bring up, so it's different than gambling, but it's just a good example of what can happen with this kind of technology, is there's a company called VROTORS that lets you play with live drones with cameras mounted and play basically war games with them. So what they do on the screen is they present these target windows that you try to fly through. So the company's based in California, and they're outside Los Angeles, and they actually have people that have drones that are up in the air, and you can take control of them remotely. So you have a pilot, you may have a co-pilot, and you may have passengers watching you, and you have your own drone, and you can actually pilot a live drone from wherever you are. And this is using this real-time streaming WebRTC video, so that the video you see is controlling this from halfway around the world. And you try to fly it through these little hoop targets that you see, and as you fly through them, you gain points. And the idea is to gain as many points as you can, and you have multiples going on. There's even some versions that they put up some targets you can shoot at, so you can have some of your co-pilots, mounting weapons and shoot at them. It's pretty exciting. It's all done online, and it's all available because of WebRTC. So we'll drop that and get back to our gambling now. So this is like the jump seat view on this, where you can see what the pilot sees and you can do your shooting. All right, so challenges for online gaming. So as I mentioned before, this is the perfect storm of huge sums of money and personal data. So you have consumers that are playing online, and you have their credit card numbers and lots of that data. So it's a prime target for people to try to attack. A lot of casinos have more cash transactions per minute than some of the world's largest banks, if you think about it. So that really ups the stakes on this. The other thing is that cyber attacks just always get, the size of them increases, but even more important, the sophistication is getting, they get more sophisticated every year. So those of us that are in the security business that work on this, we know that we have to keep upping our game in terms of how to detect these new sophisticated attacks, how to mitigate them and attack them. And it's just like a war game. We learn how to attack them. Cyber criminals come up with new ways of attacking. We solve them, and on it goes. And, just to multiply the problem, casinos have online websites, you have mobile apps, there's multiple points of entries. And, just sorry for the pun, but, the industry can't gamble on poor security. So to combat this, you really need basically a layered approach. I talked about things you get with any CDN, about encryption, access control, geo-blocking, and all that. You probably also want to have web application protection. So all your web apps is where your gamblers and consumers log in and has all their personal data, credit card numbers. So that's the prime target of these nefarious bot attacks. So you really need to have a good web application firewall that can adapt to your web apps and watch for good bots and bad bots, and keep them out. If you can't tell the difference between a good bot and a bad bot, you don't know if you're under attack. So it's critically important. There are good bots. That's how the web works. They can discover what content you have and link people to it. So it's important to have bots, but gotta watch the bad ones. So as a summary, you need to clearly understand what latency your gaming use case requires. So we talked about a bunch of different technologies there and so it's really important to know what you really need. To match the broadcast with simultaneous streaming, easy to meet with HLS and Dash small chunk, and you have plenty of infrastructure to do that. Leverage CDN video workflows. You can do a lot of transcoding, and you can do a lot of that yourself and just deliver that. But if you want to really go on a massive scale, CDNs have on cloud-based services that can basically offload all this from you. It's a flexibility you have. You can go either way. And again, implement best practices, cybersecurity measures. They're just critically important. So just as a wrap up, I think this might be available to download. This is a white paper I wrote about how low latency streaming changes the video landscape, and it's just pure technology, how all these different technologies work in depth. It might be available for download, or you're going to get a follow-up to this with a link to view the recorded version. So if some friends of yours haven't been able to see this video webinar live, they can watch it online, and from that point, there'll be a link to download this white paper as well. All right, so I thank you very much for this. I hope this was instructive and you learned something from it, and we look forward to having you again on a future webinar. Have a good day.